everybody, how are you? I hope you are doing very well. Today inshallah guys, we are gonna start a new chapter, electrochemistry. Our first section will be introduction to electrochemistry, so I hope you will enjoy it. So the objectives of this section, guys: number one, identify parts of an electrochemical cell and their functions. Number two, we will learn how to write electrode half reactions for cathodes and anodes. So today inshallah we will learn what do we mean by electrochemistry as a science, what do we mean by electrochemical cell, what is the component of the electrochemical cell, what is the meaning of electrode, the cathodes and anodes, and all this stuff. Okay, so guys, as we know, so far we have learned about oxidation reduction reactions, and we say that oxidation reduction reactions are kind of reactions that involve transfer of electrons. Okay, so because oxidation reduction reactions involve electron transfer, the net release or net absorption of energy can occur in the form of electrical energy rather than as heat. Okay, the branch of chemistry that deals with electricity related applications of oxidation reduction reactions is called what? Electrochemistry. So this is what we mean by electrochemistry. Again, as the branch of chemistry that deals with electricity related applications of oxidation reduction reaction. So guys, as we said, oxidation reduction reactions involve a transfer of electrons between two different half cells, okay, or half reactions. So if the two substances are in contact with one another, a transfer of energy as heat accompanies the electron transfer. Okay, while if the substance that is oxidized is separated from the substance that is reduced, as we will see in the electrochemical cell, the electron transfer is accompanied by a transfer of electrical energy instead of energy as heat. So what do we mean by this, guys? Let us see the next slide. So guys, as we can see here in this beaker, we have a zinc strip, and this zinc strip is in direct contact with the copper sulfate solution, and we have here what? A thermometer. Okay, so right now guys, we expect that oxidation reduction reaction will take place between the zinc atom and the copper ions in this solution. Now the zinc atom will lose electrons, and these electrons will be accepted by the copper ion or the copper ions in this solution. Okay guys, now what will happen? The copper ions will accept the electrons and fall out of the solution as what? As copper atoms. So guys, as electrons are transferred between zinc atom and copper ions in the solution, energy is released as heat, as indicated by the rise in temperature. So again guys, as we said, if the oxidation reduction reaction, or if the substance that is being reduced and the substance that is oxidized are in direct contact with one another, then as we said guys, the transfer of energy as heat accompanies the electron transfer. Okay, but as we said, if the substance that is oxidized separate from the substance that is reduced, and they will be separated in a certain way as we see later, then the electron transfer is accompanied by transfer of electrical energy instead of energy as heat. Okay, so guys, we can consider this as an electrical or electrochemical cell, as we said, because the substance that is oxidized and the substance that is reduced are not separated are not separated by a barrier. Then here we do not expect any change in the electrical energy during the electron transfer. Okay, so electrochemical cells, guys, here we need to identify the main parts of the electrochemical cells. Okay, so guys, as we can see here, we have two electrode we have the zinc electrode on this side. On the other side we have copper electrode, and as you can see, both sides are separated by what? A barrier, and this barrier is called a porous barrier or salt bridge. So guys, a porous barrier or salt bridge can be used to separate the oxidation and the reduction half reaction. Okay, so as we said, in electrochemical cell, the substance that is reduced and the substance that is oxidized, sorry, of course, it will be the opposite. So the substance that will be oxidized and the substance that is reduced should be separated by a barrier, and this barrier is called porous barrier or salt bridge. So guys, as we can see here, as we said, we have two electrodes, zinc electrode and copper electrode, and as we can see here, each electrode is in contact with what? With an electrolyte. The zinc electrode is in contact with the zinc sulfate electrolyte, and when we say electrolyte, we know that this kind of solution can conduct electricity, right? The copper electrode is also in contact with what? With the copper sulfate electrode. So guys, as you can see, each electrode with their electrolyte will make up what? Will make up a half cell. So here we have the zinc electrode with the zinc sulfate electrolyte making up a half cell, and here we have the other half cell that is made up of copper electrode with what? With the copper sulfate electrolyte. Both of the half cells are separated by what? By the salt bridge or the barrier or the porous barrier. So guys, as we said, what is the advantage of this barrier? What do you think? Exactly, the barrier here prevents the metal atoms of one half reaction from what? From mixing with the ions of the other half reaction. Okay, so here ions in the two solution can move through what? Through the porous barrier, which keeps a charge from building up on the electrodes. Okay, what about guys the electrons that will be released during the oxidation reduction reaction? These electrons, guys, as you can see here, can be transferred from one side to another through an external connecting wire. So here, this is the advantage of this conducting wire, just to transfer the electrons from one side to another, and these electrons, as I said, will be released during the oxidation reduction reaction. Okay, so guys, as we said, here we have the zinc strip, and the zinc strip is in an aqueous solution of zinc sulfate, ZnSO4. The same is for the copper strip, guys. The copper strip is in an aqueous solution of what? As I said, copper sulfate CuSO4. So both solutions actually, guys, as I said, conduct electricity. Why? Because both of them are electrolytes. So guys, what do we mean by electrodes? Electrode is a conductor used to establish electrical contact with what? With a non-metallic part of a circuit, such as what? Such as an electrolyte. So again, guys, electrode is what? Is a conductor used to establish electrical contact with a non-metallic part of a circuit, such as an electrolyte. Okay, so guys, here in this figure, the zinc and copper strips are what? As we said, are electrodes. A single electrode immersed in a solution is what? Is a half cell. So this here we have two half cells. Zinc electrode represent the first half cell, the copper electrode represent the second half cell. So guys, another diagram to show how ion will move, or ions will move through a porous barrier. Okay, then again, electrochemical cell, we have two electrodes, the zinc strip, the copper strip. Zinc strip is immersed in zinc sulfate solution, copper strip is immersed in copper sulfate solution, and here between them, guys, we have the salt bridge or the porous barrier that will allow for certain ions to move through it. So guys, here we can see that the zinc ion is moving from the left side to the right side, and sulfate ions are moving in the opposite direction. Okay, so guys, again, as we said, electrons can be transferred from one side to the other through an external connecting wire, as we can see here, guys. Okay, electric current moves in a closed loop path or circuit, so this movement of electrons through the wire is balanced by what? By the movement of ions and solution. So as we said, we have defined the electrode, and we said an electrode is a conductor used to establish electrical contact with a non-metallic part of a circuit, such as an electrolyte. And we said we have in each electrochemical cell we should have what? We should have 2 electrodes. Okay, then we moved where here, guys, as we said, a single electrode immersed in a solution of its ions is what? Is a half cell. So guys, remember when we talked about half reactions, at each half cell, half reaction will take place. One of them at one side, or in one half, we will have an oxidation reaction. On the other side, or on the other electrode, we will have what? Reduction reaction. Okay, so guys, the electrode where oxidation occurs is called what? The anode. Okay, while the electrode where reduction occurs is called what? The cathode. So again, anode is the electrode at which oxidation will take place, while anode, or sorry, cathode is the electrode at which what? At which reduction will take place. So guys, what do you think here? At this side, what do you expect? Do we have here an oxidation reaction or reduction reaction? Guys, here actually we have an oxidation reaction here, because the zinc atom will lose 2 electrons, and the copper here, the copper ions will accept these 2 electrons. Okay, so guys, zinc strip represent what? Represent the anode at which oxidation will take place, while the copper strip represent what? Represent the cathode at which reduction will take place. Okay, so guys, as you can see here, okay, at the anode, which is here in this example, the zinc strip, we can see that the zinc atom lost 2 electrons. That's why the zinc strip considered to be what? Anode, because here we have oxidation reaction, and we remember that the oxidation reaction involve what? Involve the loss of a number of electrons. Okay, while guys, on the other strip, which is the copper strip, the copper strip is cathode. Why? Because copper will gain the electrons that that has been released from the zinc. Okay, so copper plus 2 electrons will give us, as we said, copper atom. Okay, that will fall out of the solution at the end of this reaction. Okay, so again, anode is the electrode where oxidation occurs. Cathode is the electrode where reduction occurs. Okay, so guys, what about the movement of the electrons through the electrochemical cell? It will be always from the anode to the cathode. Okay, from the anode to the cathode. Why? Because we say that anode is the place where oxidation takes place, and here, when certain atom is oxidized, or certain substance is oxidized, it will release electrons. So this released electrons will move through the this wire to the other side. So always, guys, the electrons will move from where? From the anode to the cathode. Why? Because at the anode, oxidation will take place and electrons will be released. So guys, both oxidation and reduction must occur in an electrochemical reaction, as we showed you. The two half cells together, guys, will make what? An electrochemical cell. So each electrochemical cell is made up of what? Of two half cell. One half cell contain the anode, the other half cell contain the cathode. At anode, oxidation will take place. At cathode, reduction will take place. During the oxidation reaction, as we said, electrons will be released, and these electrons will move from the anode to the cathode. Okay, all together, guys, all these compartments together will give us what we call an electrochemical cell. Okay, so guys, the complete cell, which is the complete electrochemical cell with both sides and with all with the anode and with the cathode and with the connected wire and with all these compartments, guys, is called the complete cell. An electrochemical cell may be represented by the following notation. So guys, here's how we can represent the complete cell. As we said, each electrochemical cell is made up of what? Of anode immersed in a solution, a cathode immersed in a solution, separated, guys, by what? By the salt bridge or the porous membrane, and at the end all of these is connected by what? By an electrical wire that will transfer the electrons between the anode and the cathode. Okay, so guys, again, anode, electrode immersed in anode solution, and this half reaction, or this half cell, sorry, is separated from the other half cell that is made up of what? Made up of cathode solution and what? Cathode electrode. So this is how we can, guys, represent the electrochemical cell or the complete cell. So guys, here the double line represent what? Represent the salt bridge or the porous barrier. Okay, so again, guys, we have the anode electrode immersed in anode solution, separated, this half cell separated by a porous membrane from the cathode solution that in which the cathode electrode is immersed. Okay, so guys, for the example that we have described, if we want to write the reaction using the same way that I describe it here in this slide, it will be this way, guys. The zinc strip or the anode here immersed in what? In the aqueous solution that contain the zinc ions, separated from the copper ions in the other side, or in the other cell, and this solution in which the copper cathode is immersed. Okay, and we can apply the same method for all the oxidation reduction reaction. Okay, guys, so now the electrochemical reaction can be found by adding the anode half reaction to the cathode half reaction. The overall or net reaction for the zinc copper cell will be as following, guys. Zinc plus copper ions will yield what? Will yield the zinc atoms, or zinc, sorry, ions, and the copper atoms. So as we said, the zinc here is oxidized because it lost 2 electrons, so the atom, the zinc atom here will become what? Will become an ion, so it will become an ion, while for copper ion on the other side of the cell, copper, as we said, is reduced. Then this copper ion will accept the electrons from the zinc, and it will what? It will form the copper atom. Okay, guys, an electrochemical cell that consists of this zinc and copper reaction is called what? Is called the Daniell cell. So Daniell cell is an electrochemical cell that consists of what? Zinc, in which the zinc is the anode, and copper, in which the copper is the cathode. Okay, so guys, that's all for today. Thank you, and please there is like 3 questions in the formative assessment at the end of this lesson. Please try to answer question number 1 and question number 2, and if you can, please send the answers to my email. Okay, so thank you, and see you inshallah later.